So next prove that cos hx power 4 minus sin hx power 4 is equal to cos h to x. We have to prove. So now taking the left hand side, so LHS is given cos hx power 4 minus sin hx power 4. So cos h power 4x minus sin h power 4x. So which can be written as, so cos h square x whole square minus, so sin h square x whole square. So now it becomes, suppose if you treat this is a and here sin h square x is b, so which is in the form of like a square minus b square. So which is in the form of like a square minus b square. We know that a square minus b square is a minus b into a plus b. We know that a square minus b square is a minus b into a plus b. So now here, so a minus b means a is cos h square x. So minus b is sin h square x, sin h square x. So into a plus b, that is cos h square x plus sin h square x, plus sin h square x. See, observe that we know the identity. So cos h square x minus sin h square x is equal to 1. We know the hyperbolic identity cos h square x minus sin h square x is equal to 1. Now which is replaced by 1 into, so this is cos h square x plus sin h square x. So finally what we get here, so 1 into cos h square x plus sin h square x is, so cos h square x plus sin h square x. So which is also one of the formula, that is cos h to x, cos h to x is equal to, also we have cos h square x plus sin h square x, and also we have here 2 cos h square x minus 1, and also 1 plus 2 sin h square x. We have the cos h to x formula. So cos h square x plus sin h square x is equal to, we can write cos h to x. So which is only the RHS, which is only the right hand side we require to prove. So therefore LHS is equal to RHS. So therefore like this we can prove that cos h power 4x minus sin h power 4x is equal to cos h to x. In this video we are going to discuss that hyperbolic functions, 2 marks, PYQs. Prove that cos hx plus sin hx whole to the power of n is equal to cos h nx plus sin h nx. So in the solution, taking LHS is, we have cos hx plus sin hx whole to the power of n. So we know that cos hx is e power x plus e power minus x by 2, and plus sin hx is e power x minus e power minus x by 2, so whole to the power of n. So now here if you take the LCM is 2, so we get e power x plus e power minus x plus here e power x minus e power minus x, so whole to the power of n. So now if you observe here, plus e power minus x minus e power minus x gets cancelled. So we get here, so e power x plus e power x, 2 e power x by 2 whole to the power of n. So 2 gets cancelled, which is equal to e to the power of x whole to the power of n. So which becomes like a to the power of m whole to the power of n. So which is e power nx. So therefore, so the left hand side LHS is equal to e power nx we get. So now coming to the right hand side, if you take RHS, if you take the RHS, so cos h n x plus sin h n x, so which is equal to cos h n x is like cos hx. So here in place of x we have nx, so we can write this is like e power nx plus e power minus nx whole by 2, and plus this is e power nx minus e power minus nx whole by 2. So which is equal to, so 2 is the LCM. Now e power nx plus e power minus nx plus here e power nx minus e power minus nx. So here also e power minus nx and minus e power minus nx gets cancelled. E power nx plus e power nx is what? So 2 e power nx whole by 2. So now 2 gets cancelled, which is equal to e to the power of nx. So therefore the right hand side also we get e power nx. So therefore LHS is equal to RHS. Therefore LHS is equal to RHS. Both the values we get. So e power nx, e power nx. Finally you can write, so cos hx plus sin hx whole to the power of n is equal to cos h nx plus sin h nx. So hence proved. So in this we are going to discuss, if sin hx is equal to 5, then prove that x is equal to log of 5 plus root 26 base e. So given that sin hx is equal to 5. So from this what we can write, x is equal to sin h inverse of 5. X is equal to sin h inverse of 5. So now we have sin h inverse x is equal to sin h inverse x is equal to, we have the formula log of x plus root over x square plus 1 base e. We have the formula sin h inverse x is equal to log of x plus root over x square plus 1 base e. So now what I am finding, we required here sin h inverse of 5. See, compare this sin h inverse of x and sin h inverse of 5. So we have to replace in this formula x by 5. So therefore from this sin h inverse of 5 is equal to log of, so x is replaced by 5 plus root over, so this is 5 square plus 1 base e. So now sin h inverse of 5 is equal to log of, so which is 5 plus, so 25 plus 1, so this is root 26 base e. Now sin h inverse of 5, see here we have sin h inverse of 5 is equal to x here. Since sin h inverse of 5 is equal to x, so that's why now here sin h inverse of 5 left hand side is replaced by x. So that's why x is equal to log of 5 plus root 26 base e. Like that, sin hx is equal to 5 is given. We can prove that x is equal to log of 5 plus root 26 base e. See here, we have to prove that cos hx minus sin hx whole to the power of n is equal to cos h nx minus sin h nx. So now in the solution, taking here left hand side, so we have cos hx minus sin hx whole to the power of n. So here we know that cos hx formula in terms of e power x here plus e power minus x by 2 and minus sin hx is e power x minus e power minus x by 2 whole to the power of n. So which is equal to, if you take the LCM here, we get e power x plus e power minus x and minus of e power x minus e power minus x whole to the power of n. So now here, which is equal to e power x plus e power minus x, which becomes minus e power x, and minus into minus is plus e power minus x whole divided by 2 whole to the power of n. See, if you observe here, e power x gets cancelled. Now e power minus x plus e power minus x, that is 2 e power minus x whole to the by 2 whole to the power of n. So now these two are gets cancelled. Now e power minus x, which is e power minus x whole to the power of n, so which is equal to e to the power of minus nx, like a power m whole to the power of n, so a to the power of mn. So like that we get here e to the power of minus x, which is LHS is equal to, finally we get e to the power of minus x. So similarly you have to take that RHS. So here the left hand side we have here cos hn x minus sin hn x. See, observe here, cos hx means we have the formula e power x plus e power minus x by 2. Same like that, in place of x, here we have nx. So that's why we can write cos hn x is e power nx minus e power minus nx whole divided by 2 minus, here same like this, e power nx plus e power minus nx whole divided by 2. So now if you take the LCM here, LCM is 2. So now e power nx minus e power minus nx, and here minus of e power nx, and here plus e power minus nx, e power minus nx. So now here we get, so e power nx cos hn is nothing but e power nx plus e power minus nx. So sin hx is here e power nx minus e power minus nx. So that's why here we get, this is plus and this is minus. So observe carefully. So here e power nx plus e power minus nx minus of e power nx minus e power minus nx whole divided by 2. Now e power nx plus e power minus nx, so minus e power nx, so minus into minus is plus e power minus nx whole divided by 2. So now here, so e power nx gets cancelled, like e power x here gets cancelled. Same like that here, e power nx gets cancelled. So now which is equal to e power minus nx plus e power minus nx is 2 e power minus nx whole divided by 2. 2 gets cancelled. Now we get e power minus nx. So therefore RHS is also, we get e power minus nx. See, observe here, so LHS is equal to, here RHS, LHS is also e power minus nx, RHS is also e power minus nx. So therefore finally we can write, so cos hx minus sin hx whole to the power of n is equal to cos hnx, so minus sin hnx. So we can prove like this. Hyperbolic functions, 2 marks, PYQs. Question: if sin hx is equal to 3 by 4, find cos h2x and sin h2x. So here given that sin hx is equal to 3 by 4. See, we know that cos h square x minus sin h square x is equal to 1. So from this we can find cos hx here. This implies cos h square x is equal to 1 plus sin h square x. So in this we have sin hx is 3 by 4. Now replace which is 1 plus sin hx is 3 by 4 whole square. Now which is equal to 1 plus, this is 9 by 16. So which is equal to 16 plus 9 by 16. This is 25 by 16. So which is equal to, so cos h square x is equal to 25 by 16. So from this cos hx is equal to, we get root 25 by 16. So finally therefore cos hx is equal to, we get 5 by 4. Cos hx is equal to, we get 5 by 4. Now here we have to find cos h2x. So therefore cos h2x is equal to, we have the formula 1 plus 2 sin h square x. Or else you can apply 2 cos h square x minus 1 also. See here already sin hx is equal to 3 by 4 is given. So 1 plus 2 into, so this is sin hx is 3 by 4 whole square. So now from this we get, so cos h2x is equal to, cos h2x is equal to, see here 1 plus, so 2 into, 1 plus 2 into, so this is 9 by 16. So we get here, which can be cancelled by 8 times, so we get 1 plus 9 by 8, which is 8 plus 9 by 8, so we get 17 by 8. So therefore cos h2x is equal to, so we have 17 by 8. So similarly further we have to find sin h2x. So sin h2x is equal to, we have the formula 2 sin hx into cos hx. So 2 sin hx into cos hx is the formula for sin h2x. So now here which is equal to, that is therefore sin h2x is equal to, so 2 into sin hx is we have, so 3 by 4, sin hx is we have 3 by 4 into cos hx is, we have here already we found cos hx is 5 by 4. So finally we get, if we cancel this is by 2 times, so 5 into 3, that is 15 by 8. So therefore sin h2x is equal to 15 by 8. So like this we can find, when sin hx is given 3 by 4, we can find that cos h2x is, by applying the formula cos h2x is equal to 1 plus 2 sin h square x. So here sin hx is replaced by 3 by 4 whole square. So we get finally cos h2x is equal to 1 plus 2 into, that is 9 by 16. So by cancellation we get 1 plus 9 by 8. So which is equal to 17 by 8. Similarly sin h2x is equal to, we have 2 sin hx into cos hx. So sin h2x is equal to 2 into sin hx is 3 by 4 into cos hx is, already we found here 5 by 4. So that's why which is 15 by 8 we get by cancellation. So therefore sin h2x is equal to 15 by 8. Like this we can find the given values. Next. So hyperbolic functions, 2 marks, PYQs. If sin hx is equal to 3, then show that x is equal to log of 3 plus root 10 base e. So here solution, given that sin hx is equal to 3. So we have to show that x is equal to log of 3 plus root 10 base e. So sin hx is equal to 3 means from this we can write x is equal to sin h inverse of 3. Sin h inverse of 3. X is equal to sin h inverse of 3. So what we have to show that x is equal to log of 3 plus root 10 base e. But we know that sin h inverse x is equal to, so we have the formula, so log of x plus root over 1 plus x square base e. So we have the standard formula sin h inverse x is equal to log of x plus root over 1 plus x square base e. See, observe here, sin h inverse of x is like sin h inverse of 3. So that's why now I am finding, therefore sin h inverse of 3, compare these two. So replace here in this formula x by 3. So we get, so here log of, so x plus, see log of x plus, what is x here? X is 3. So that's why here 3 plus, so root over 1 plus 3 square base e. So we get sin h inverse of 3 is equal to log of 3 plus root over 1 plus 3 square base e. But actually what is sin h inverse of 3 here? Sin h inverse of 3 is x. So that's why here x is equal to log of, so 3 plus, so root over, this is 1 plus 3 square, that is 1 plus 9. So we can write base e here. So finally we get x is equal to log of 3 plus root 10, so base e. 3 plus root 10 base e. So like this we can prove when sin hx is equal to 3 is given. So then x is equal to log of 3 plus root 10 base e. Next. So here in this we are discussing hyperbolic functions, 2 marks, PYQs, previous year's questions. So prove that tan h inverse of 1 by 2 is equal to 1 by 2 into log 3 base e. So here we have tan h inverse x is equal to 1 by 2 into, so log of 1 plus x by 1 minus x base e. We have the standard form. So by using this here, we have to find the tan h inverse of 1 by 2. No. So put x is equal to 1 by 2 in this. Put x is equal to 1 by 2 in the standard form. We get therefore tan h inverse of 1 by 2 is equal to here 1 by 2 into log 1 plus 1 by 2 by 1 minus 1 by 2 base e. So now which is equal to here 1 by 2 into log 1 plus 1 by 2 is 3 by 2 by 1 minus 1 by 2 is 1 by 2. So base e, here 2 gets cancelled. So we have here 1 by 2 into log 3 base e. So therefore tan h inverse of 1 by 2 is equal to, we can prove that 1 by 2 into log 3 base e. So here what is given, very important problem this is, many times repeated in the examinations. Prove that tan h inverse of 1 by 2 is equal to 1 by 2 into log 3 base e. So we have the standard form of tan h inverse x is equal to 1 by 2 into log 1 plus x by 1 minus x base e. You have to remember this formula. So in this replace x by 1 by 2. So that means put x is equal to 1 by 2. Why? Because we have to find tan h inverse of 1 by 2. So that's why tan h inverse of 1 by 2, x replaced by 1 by 2 is equal to, here also 1 by 2 into log 1 plus x is replaced by 1 by 2 by 1 minus 1 by 2. So here we get 1 by 2 into log 1 plus 1 by 2 is, we have 3 by 2 and 1 minus 1 by 2 is 1 by 2. So 2 gets cancelled, we get 1 by 2 into log 3 base E. So like this, tan H inverse of 1 by 2 is equal to, we can prove that 1 by 2 into log 3 base E. Next. See in the hyperbolic functions, PYQs, 2 marks questions. Question is, if cos hx is equal to secant theta, then prove that tan h square x by 2 is equal to tan square theta by 2. Cos hx is equal to secant theta, then prove that tan h square of x by 2 is equal to tan square theta by 2. Now how to prove this is, here given that cos hx is equal to secant theta, and we have to find the tan h square x by 2. We know that tan h square x by 2 is equal to, in terms of cos hx, we have the formula, that is cos hx minus 1 by cos hx plus 1. Cos hx minus 1 by cos hx plus 1. So which is equal to, in this, so cos hx is replaced by secant theta. Cos hx is replaced by secant theta, which is given. So minus 1 whole divided by, here again in the denominator also cos hx is replaced by secant theta plus 1. So further, which is, we know that secant theta is 1 by cos theta. Here we know that secant theta is equal to, can be written as 1 by cos theta. So now here 1 by cos theta minus 1 by, here secant theta is also 1 by cos theta and plus 1. So further it becomes, if you take the LCM here, we get, which is equal to, so cos theta is LCM, no? We get 1 minus cos theta by cos theta whole divided by, again if you take here also the LCM, so we get 1 plus cos theta whole divided by cos theta. Is it? So now here if you observe, this cos theta and this cos theta are gets cancelled. So we have here 1 minus cos theta by 1 plus cos theta. So but we have here, for cos theta is equal to, we have, so 1 minus 2 sin square theta, 2 sin square cos theta is equal to, we have 1 minus 2 sin square of theta by 2, and also here we have 2 cos square theta by 2 minus 1. See from this, from the first one, so 1 minus cos theta, from the first one 1 minus cos theta is equal to, we get 2 sin square theta by 2. This is the formula for 1 minus, from the first one here we get 1 minus cos theta is equal to 2 sin square of theta by 2, and from the second one we get 1 plus cos theta is equal to 2 cos square theta by 2. See, observe here carefully, 1 minus cos theta is 2 sin square theta by 2, and 1 plus cos theta is from the second one, so 2 cos square theta by 2. So here 1 minus cos theta in the numerator replaced by 2 sin square theta by 2, and 1 plus cos theta in the denominator replaced by 2 cos square theta by 2. So now here, if you observe, numerator and denominator 2 gets cancelled. We have here sin square theta by 2 by cos square theta by 2. So which is equal to, finally we get, so tan square theta by 2. See, observe here. So therefore we require to prove tan square theta by 2 only. Therefore tan h square of x by 2, so which is equal to tan square of theta by 2. So like this we can find the solution. So this is the final solution. In this video we are going to discuss hyperbolic functions, 2 mass cosines, PYQ cosines, previous year's cosines. Very important problem, many times repeated in the examinations. If cos hx is equal to 5 by 2, then find the values of cos h2x and sin h2x. So here given that cos hx is equal to 5 by 2. Given that cos hx is equal to 5 by 2. From this I am finding sin hx. So we know that the identity cos h square x minus sin h square x is equal to 1. So from this we can write sin h square x. From this we can write sin h square x is equal to cos h square x minus 1. So from this now sin h square x is equal to this cos hx, we know that 5 by 2. So that's why this is 5 by 2 whole square minus 1. So which becomes 25 by 4 minus 1. So finally, which is after taking the LCM, we get 25 minus 4 by 4, which is equal to 21 by 4. So from this, so we have sin h square x is equal to 21 by 4. So therefore, we require sin hx. Sin hx is equal to root 21 by 4. So we get root 21 by 2. So this implies finally we get sin hx is equal to root 21 by 2. So from this we can find cos h2x and sin h2x also. Now first given thing, to find the value of cos h2x, so which is equal to, with the help of cos hx also we can find. So cos h2x, we have 2 cos h square x minus 1. This is the formula for cos h2x. So now which is equal to 2 into, here cos hx is replaced by 5 by 2 whole square minus 1. So which is equal to 2 into, here 5 by 2 whole square is nothing but, so 25 by 4 minus 1. So which becomes 25 by 2 minus 1. So after taking the LCM, we get 25 minus 2 by 2, which is equal to, we get 23 by 2. So therefore, so cos h2x is equal to, we get 23 by 2. So like this, we can find cos h2x. Similarly, to find sin h2x, the second thing is given here, sin h2x. Now sin h2x is equal to, we have the formula, so 2 sin hx into cos hx. So which is equal to, you know the value of cos hx 5 by 2, and here, so cos hx is 5 by 2, and here sin hx is root 21 by 2. So both you can substitute. So we get here, so which is equal to 2 into, so 2 into sin hx values we have root 21 by 2 into cos hx is given here 5 by 2. So finally we get 2 gets cancelled. So we get here 5 root 21 by 2, which is sin h2x. So therefore sin h2x is equal to 5 into root 21 by 2. So like this we can find the value of cos h2x and sin h2x when given cos hx is equal to 5 by 2.